In this video, I will walk you through free response question number 3 from the 2023 AP Calculus exam. This problem is primarily about slope fields, differential equations, and tangent line approximations. A bottle of milk is taken out of a refrigerator and placed in a pan of hot water to be warmed. The increasing function m models the temperature of the milk at time t, where m of t is measured in degrees Celsius, and t is the number of minutes since the bottle was placed in the pan. M satisfies the differential equation dm dt equals 1/4 40 minus m. At time t equals 0, the temperature of the milk is 5 degrees Celsius. It can be shown that m of t is less than 40 for all values of t. Part A. A slope field for the differential equation dm dt equals 1/4 40 minus m is shown. Sketch the solution curve through the point 0, 5. In order to draw the solution curve through the point 0, 5, we need to start at 0, 5, and then we just follow the flow suggested by the slope segments of the slope field as we move to the right. This string of horizontal slope segments represents an asymptote, so our curve should approach this asymptote as we go to the right. Your sketch should look something like this. Part B. Use the line tangent to the graph of m at t equals 0 to approximate m at 2, the temperature of the milk, at time t equals 2 minutes. To write the equation of the tangent line, we will need a point and the slope. For the point, we can just use the point of tangency, which is at 0, 5. To find the slope, we just need to evaluate the derivative at 0, 5. That's 1/4 40 minus 5, which is 35/4. So the equation of the tangent line will be y minus y, so y minus 5, is equal to the slope, 35/4, times x minus x, so x minus 0. So simplifying this a little bit, we have y minus 5 is equal to 35/4 x, and adding 5 to both sides, we get y equals 35/4 times x plus 5. So this is our tangent line equation. One small correction. Instead of x and y, we should be using the variables t and m. Let's use this tangent line equation to approximate the value of m at 2. So m at 2 will be approximately equal to 35/4 times 2 plus 5. Remember that m represents the temperature of the milk in degrees Celsius, so as long as you include the units, you could leave your answer just like this. If you simplify your answer, you get m at 2 is approximately 22.5 degrees Celsius. Part C. Write an expression for the second derivative of m in terms of m. Use the second derivative to determine whether the approximation from Part B is an underestimate or an overestimate for the actual value of m at 2. Give a reason for your answer. We were given this expression for dm dt. If we do the distributive property, we get dm dt equals 10 minus 1/4 m. Taking the derivative of both sides with respect to t, we get the second derivative equals negative 1/4 dm dt. We can't leave the answer like this, but we know that dm dt is equal to 10 minus 1/4 m. So we can just take this expression and substitute it in right here. This is our expression for the second derivative in terms of m. Now we need to somehow use this second derivative to determine whether the approximation from Part B is an underestimate or an overestimate. It's all about concavity. If m of t is concave up on the interval in question, then the tangent line will underestimate, because the tangent line is below the curve. If m of t is concave down on the interval in question, the tangent line overestimates because the tangent line is above the curve. We can use the second derivative to determine whether m of t is concave up or concave down on various intervals. If the second derivative is positive on a given interval, m of t is concave up. If the second derivative is negative, m of t is concave down. Notice that in the setup of the problem, we were told that m of t is always less than 40. So the question is, if m is less than 40, does that make the second derivative positive or negative? Let's start by plugging in 40 itself, and let's see what happens. If m is exactly 40, we have 1/4 times 40, which is 10. So we end up with 10 minus 10 right here, which is going to be 0. So if m is anything smaller than 40, then this number right here is going to be something smaller than 10. So for example, imagine that this was a 9. In that case, we would have 10 minus 9, which is a positive number, but then we have this negative 1/4 in the front, which makes it negative again. So if m is anything less than 40, this expression is going to be less than 0. Since m of t is less than 40 for all t, the second derivative is negative for all t, so m of t is concave down for all t. The tangent line approximation is an overestimate because the tangent line is above the curve for all t. Part D. Use separation of variables to find an expression for m of t, the particular solution to the differential equation dm dt equals 1/4 40 minus m, with the initial condition m at 0 equals 5. Using separation of variables to solve a differential equation means getting all of the m's on the left side of the equation and all of the t's on the right-hand side. So I think I'll start by multiplying both sides of this equation by dt and sort of moving the dt over here. So far we have this. Notice that we have the t on the right-hand side, but we still need to move this m somehow to the left-hand side. As we do this algebra, we can only multiply and divide. Adding and subtracting will give us equations that we can't integrate. So in order to move this expression to the other side, we want to divide both sides by 40 minus m. That's going to give us a 1/40 minus m on the left. You can leave this 1/4 right where it is. Now that we have all of the m's on the left and the t's on the right, we can integrate both sides of the equation. I'm going to integrate the left-hand side using a mental u substitution. Imagine that this denominator is u. So we have the integral of 1 over u. That's going to be the natural log of the absolute value of u. Now you can only integrate with respect to u and not m if you divide by u prime. The derivative of this u is -1. Moving that negative up to the front, we have this. For students who are not comfortable with mental u substitution, I'm going to go ahead and do it out. If we let u equal 40 minus m, that means u prime is equal to -1. So we could rewrite this integral as the integral of 1 over u, and then instead of dm, we write du over u prime. That's du over -1. Of course, I'm going to put this -1 out in the front on the next step, but the integral of 1 over u is the natural log of the absolute value of u. And I would go ahead and substitute back in this 40 minus m, and like I said, the -1 goes out in the front. So that's how you would do it if you wanted to sort of show it out the long way. Normally when we integrate we put a plus c, but we don't need the plus c on both sides of the equation, and I'm going to save it for the right hand side. the antiderivative of 1/4 with respect to t is 1/4 t. And there's your plus c. Now it's time to use the initial condition 0, 5, I'm getting that from this, in order to find the value of c. So at 0, 5, we get negative natural log absolute value of 40 minus 5, and that's going to equal 1/4 times 0 plus c. So that's negative natural log absolute value of 35. I don't need the absolute value anymore, so I'm just going to put negative natural log 35 is equal to c. So let's take this expression and substitute it in for c. I'm going to go ahead and drop the absolute value now because 40 minus m is always positive because we were told that m is always less than 40. So I just need to solve this equation for m. I need to get m by itself because they said find an expression for m of t. So I need to get m alone. I would like to get rid of this negative sign, so I think I will just multiply both sides by -1. So that's going to give me natural log 40 minus m is equal to, and this would be negative 1/4 t plus natural log 35, but I think I will write this switched around. So now we have this. To make this natural log go away, I can exponentiate both sides of the equation. In other words, I can drop a base e on both sides, making both sides the exponent of these e's. When you raise e to a natural log expression, the e and the natural log cancel each other out, and you end up with 40 minus m is equal to all of this, e to the natural log 35 minus 1/4 t. Be careful, all of this is up here in the exponent. Adding m to both sides and subtracting this expression from both sides gives us this. I'm just going to flip it around for the final answer. And that's it. A bit of an ugly answer, but there you go. Actually, you can leave your answer like this, but we can also simplify a little bit more. First, a quick side lesson. If I had e to the a times e to the b, how would I simplify this? This would be e to the a plus b. But what if we flip this around? If I gave you e to the a plus b, wouldn't this be the same as e to the a times e to the b? It's just the reverse of what we did the first time. So anytime I have e and a sum or a difference, I can turn that into a multiplication problem. But that's what we have right here. I have e to the a minus b. So I could rewrite this part as e to the a times e to the negative b. So now we have m of t equals 40 minus e to the natural log 35 times e to the negative 1/4 t. But this part can simplify because now the e and the natural log can cancel each other out, leaving behind the 35. So the simplified answer looks like this.